We are going to talk about still chapter 9 and we're going to focus on monsoons. And we're going to talk monsoons in detail. Okay, so monsoons. The major monsoon regions of the tropical extend from Australia, Indonesia in the east through Southeast Asia and the India subcontinent. So right here. And across Africa to West Africa. There is a separate region in northwest Mexico and the southwest United States, and another in Central South America. The term monsoon is derived from the Arabic word mawsim, meaning season. It refers to the major seasonal wind reversal over southern Asia from northeasterlies in winter to southwesterlies in summer, in response to the different patterns of land and sea, heating, and temperature contrast. Basically, air flows from the cooler ocean to the heated land in summer and in the opposite direction in winter. However, it is a very simplistic view. There is a heat lobe over northern India in spring with air flowing toward it. But this is well before the onset of the southwest monsoon and its heavy rains. To understand the South Asia monsoon, we need to examine the upper air circulation over the region. In winter, the upper-level westerlies are split by the Tibetan Plateau and the subtropical jet stream flows eastward south of the Himalaya, while the polar front jet stream is well to the north over Siberia. Air subsides beneath the exit of the subtropical jet stream due to high-level convergence as the air slows down, and this sinking air gives rise to the low-level northeasterly winds that flow out of India over the Indian Ocean. In May, the subtropical jet stream begins to shift northward, and in June, the heating of the Tibetan Plateau, which averages 4 to 500 meters elevation or 600 millibar, creates a shallow heat low and an upper-level anticyclone. The anticyclone gives rise to upper-level easterly winds over India and forms the tropical easterly jet stream around 150 millibar, around 13.5 kilometers at about 15 degrees north. At low levels, warm, moist southwesterlies flow over the Indian Ocean, pushes northeastwards toward India. However, the monsoon onset begins over Burma and Assam because the rain-bearing systems are monsoon depressions that travel to the west and northwest steered by the high-level easterlies. Some 4 to 6 of these depressions from over the Bay of Bengal and affect India each monsoon season. The southwesterlies bring rain to the western Ghats along the west coast of India. But it is the monsoon depressions and occasional tropical cyclones from the Bay of Bengal and spread rainfall to the north and west, so that by July they reach southern Pakistan and the western Himalaya. Some moisture penetrates into southern Tibet, but there the rainfall tends to occur in convective showers at night. Bangalore in south-central India receives about 100 mm per month during May to August, but then 300 mm in September as the monsoon retreats because the Bay of Bengal depressions are then moving across India at lower latitudes. So the monsoon has irregular active and break intervals over India. The active phases of convection occur when the monsoon trough is in a northerly location and breaks when it moves to the south. The active period typically occurs at 15 to 20 day intervals and lasts about 10 to 15 days. The frequency of active periods during the summer season determines how much precipitation falls during the monsoon. There is large interannual variability in monsoon rains in both the timing and amount. For all India, the monsoon provides 78% of the total average rainfall. The mean amount for 1871 to 1990 was 852 mm, with a range from 70 to 120% above the mean according to Pathasarati et al. Totals were low from 1901 to 1930 and 1961 to 1990 and high from 1881 to 1900 and 1931 to 1960. New work shows a progressive decrease in all India rainfall since the mid-20th century from 871 mm to 811 mm in 2001 to 2010 as a result of warming in the Western Pacific warm pool and an eastward shift of the monsoon rain. During September to October, the upper easterlies weaken and disappear as the upper anticyclone over Tibet decays, setting the stage for the return of the subtropical jet stream over northern India. In winter, low-pressure systems steered by the subtropical westerlies jet stream from the Mediterranean and Middle East enter Pakistan, Kashmir, and northwest India, bringing rain and snow to the Karakoram Mountains. Over China in winter, there are frequent cold air outbreaks from the northwest related to the cold winter anticyclone over eastern Siberia. In spring, this weakens and disappears. The summer monsoon arrives in late May in the south and in late July in the far northwest of China. The moisture source is southerly flow from Indonesia and the South China Sea, not the southwesterlies over South Asia. The spring-summer 梅雨 plums rains front appears to evolve with the monsoon trough and the East Asia West Pacific polar front. Rains in China are linked to weak disturbances that move eastward along the Yangtze and occasional cold fronts from the northwest. So you can see the temperature versus in summer and winter in China. Over West Africa, the monsoon southwesterlies advance from the coast of the Gulf of Guinea in February, about 13 degrees north in May, but then in mid-June, rains occur widely from 9 to 13 degrees north. The extreme northern limit of surface monsoon air, the intertropical discontinuity or front, is at about 20 degrees north over a sufficient depth of moisture for precipitation reaches only about 13 degrees north, aloft between about 10 degrees and 17 degrees north, where it's a weak Africa. The AEJ is a result of the temperature gradient between the Sahara and the Gulf of Guinea. It drifts north-south seasonally with the advance and retreat of the monsoon, as is the case over India. Waves move westward steered by the tropical easterlies. Some of these waves may later develop into tropical storms in the western Atlantic associated with the jet streams or deep cumulonimbus clouds developed on westward moving north-south oriented disturbance lines. To the south, there is a zone of disturbances that originate over East and Central Africa. These give rise to deep stratiform cloud with prolonged light rainfall. At the coast, there is a narrow zone of frictional convergence that gives light rainfall within the monsoon air that is overlain by subsiding easterlies and easterly jet stream. AEJ at about 3 kilometers, overlain by the stronger tropical easterly jet stream at 15 to 25 kilometers, which is a continuation of the system over India. In late December, Australian summer, a thermal flow develops over northern Australia with low-level westerlies, overlain in the upper troposphere by easterly winds, and analogous to the summer pattern over India, beginning over Borneo in early November. Northwesterlies flow over Indonesia and New Guinea in December, penetrates to northern Australia. The monsoon season at Darwin averages about 75 days from 28 December to 13th of March, based on the winds between the surface and 500 millibar. Darwin shows a pronounced wet 3 month in January to March. However, the duration of the monsoon season is highly variable. Also, as in India, there are active periods of 4 to 14 days and breaks of 20 to 40 days. Much of the precipitation is associated with monsoon depressions, of which there are typically 5 per season. In the American Southwest and the Northwest Mexico, there is also a summer monsoon. The Mexican or North American monsoon, the driving factors appear to be the heating of Colorado Plateau area in June, July that leads to the development of an upper-level anticyclone analogous to Tibet and the Altiplano. Moist southerly flow affects northwest Mexico in mid-July and reaches southeast Arizona and southwest New Mexico around July 1st. Over 70% of annual precipitation in northwestern Mexico falls in June, July, and August, and over 50% in southeast Arizona and southwest New Mexico. Monsoon failures are implicated in major droughts in the southwestern United States. Surges of moisture from the Gulf of California affect lower elevations, and southwesterlies flow from the Gulf of Mexico at 700 millibar affects the higher elevations further north. The rain generally falls in brief but intense afternoon evening thunderstorms that form into clusters triggered by surface heating.